42.9 times 10 to the power 6 plus by 254 power 3 divided by 12 times 10 times 2 is equal to 27.312 times 10 to the power 6. Let me do it again. 254 power 3 divided by 12 times 2, 27. Yep. So 27.312 power 6 plus a 42.94 is equal to 70.212. Times 10 to the power 6 millimeter to the power 4. Okay, let me do it again. So the width is 254. Okay, so 10 times by 254 power 3 divided by 12 times 2 plus by 42.9 power 6 is equal to 70.212. Okay, so this is correct. Okay, so I checked the book. It is base. We are still off, but the ballpark figure is right. So now we know that this is our what? So remember what I told you? You use the I minimum, okay, more likely to buckle. Okay. Okay, it's more likely to buckle. And it's already in our help sheet, right? We put down here, right? Buckling will tend to more likely occur with the lower I value. Okay, we got this over there. Okay, so we are going to use that value over here. Now, for the allowable stress design, so so the question state that we have to use the allowable stress here. So allowable stress design. Right. The most important thing is the L over R. Right. We have to know our L over R ratio. Okay. So L over R ratio. So now we look at our L over R. So with that we have to determine the L over R. Right. So if you look at over here, our formula sheet, what formula to use is dependent on our what? On our L over R ratio. Okay, so we have to find out what is our L over R ratio first. Then we have to find our square root 4.71 square root E over stress Y. Okay, so let's do this first. Okay, so L over R ratio. So now we don't know our R. Okay, so we know that IYY is equal to A, okay, RY squared. So how do we know this formula? We have written this down before, right? We come down here, we look over here, we have written this before. It's there already. Okay, so from here, we find our RY is equal to IYY divided by A. Okay, so square root IYY is equal to 70.212 times 10 to the power minus 6. Then our area, so we know the area, it is what? 10200. Okay, so one of the area is 10200. Hold on. 10 times 10 to the power minus 6 plus. So we have the plates. So the plates is, so the width is 254 and then 10 millimeters thick. So we have to plus twice 0.254 and times by 0.01, 10 millimeters thick plate. Okay. So this will be equal to square root. I still go for 70.212 times 10 to the power minus 6 divided by 0.254 times by 0.01 times 2 plus by 10200 power minus 6 is equal to 15.28 times 10 to the power minus 3. Let me do it again. 2 times by 0.254 times by 0.01 plus y1020 power minus 6 is equal to 15.2. Okay, so this will be equal to 0.212 power minus 6 divided by 15.28 power minus 3. Square root of the whole thing is equal to 0.0 or 67.786 times 10 to the power minus 3 meters. Okay, so when you check, the answer is 67.995. What is the difference is our area is different and our top is different, but we're not so far away. Okay, so the next thing we are going to do is we're going to find our L over R ratio. So our L given to us, our L is what, 9 meters? So 9 divided by 67.786 times 10 to the power minus 3. So 9 divided by 67.786 power minus 3 is equal to 132.77. Okay, so that is our L over R based on the cross section and the length that we have. Okay, so that is our L over R ratio. Then from here, we have to determine our this function. We have now find our what do you call our 4.71. Okay, so we have to compare. Okay, compare L over R with square root of what given to us is square root of, I'm looking for my formula sheet. Okay, square root of 4.71 square root of E over stress Y. Okay, so we know that 4.71 square root of E over by square root Y. Okay, so 4.71 multiplied by square root of our Young's modulus given to us 200 times 10 to the power 9 divided by our yield strength. Yield strength is equal to 345 times 10 to the power 6. Okay, so 200, so square root of 200 power 9. Okay, wait. Square root 200 power 9 divided 345 power 6 times by 4.71 is equal to 113.403. Okay, I do it again. Square root 200 power 9 divided by 345 power 6 times by 4.71. Okay, 113. So now we know that L over R. Okay, so we know that L over R, note that L over R is greater than the value we calculated of 113.403. 0.403. Okay, so the formula or the equation that we are going to use, right? The equation that we are going to use will be equal to stress critical is equal to 0.877 stress E. Okay, so now we have to determine our stress E. So stress E is equal to pi squared E over L over R and then the whole thing squared. Okay, which we have all these values. So this will be equal to pi squared 200 times 10 to the power 9 over the length. I can't remember now. I think the length is 9. Okay, and our radius of gyration is what? 67.786 times 10 to the power 3. 67.786 times 10 to the power minus 3. So this will be equal, then the whole thing squared. Let me check again. 67.786 times 10 to the power minus 3 squared. Okay. So we have shift pi squared times by 200 power of 9 divide by 9 divide by 67.786 power of minus 3 close bracket squared. I get 111.976 times 10 to the power 6 Pascal. I do it again. 200 power 9 times by shift by 1 divide by bracket 9 divide by 67.786 power minus 3 close bracket squared. 111.976 times 10 to the power of 6. So my stress critical is equal to 0.877 multiplied by 111.976 times 10 to the power 6. Okay. So 0.877 times by 111.976 power 6. Stress critical is 98.203 times 10 to the power 6 Pascal. So I need to calculate stress allowable. So stress allowable is equal to what? Stress allowable is equal to stress critical divided by 1.67. So stress allowable is equal to stress critical divided by 1.67. So this is equal to 98.203 times 10 to the power 6 divided by 1.67. Okay, 98.203 power 6 divided by 1.67 is equal to 58.804. 58.804 times 10 to the power 6 Pascal. Okay, then the P allowable is equal to 58.804 times by 10 to the power 6, and then the area. Oh, did we calculate the area? I think we did. The area is what? 15.28 times 10 to the power minus 3. 15.28 times 10 to the power minus 3. So 58.804 power 6 times by 15.28 power of minus 3 is equal to 898.52525 times 10 to the power 3 Newton. Okay. So now I'm checking the answer manual. The answer is the same, but they use weird numbers. Okay. So Tony, you are the one that asked me this question, right? Hello?
Yeah.
Yeah. Why do you ask this question? Because the approach. So why do you like to ask you? Why do you ask this question? It's not difficult, right?
Yeah, I couldn't solve it, and in the solution I saw they use a different formula than we
Yeah.
used.
So the formula that I use now is exactly the same that what I shown you guys on the formula sheet. That's why I want to do it for you all. Okay. Also, and it's a good question. Okay. So you no doubt how they get it is different. They plug in, there's a weird number over here like pi squared over e 1.92. All this start coming in, right?
Yeah.
Don't worry about how they do it, but the most important thing is, where I underline all this, these are the critical numbers. Your number has to be the same as the solution manual. Are we clear? Okay.
Yeah.
With this in mind, I see you guys on Thursday. And Thursday, your term test will be in ETB what? 23 what? 238. Okay. 238. Okay. With that, study hard. Okay. Don't be too stressed. I'll see you guys on Thursday.
All right. Good night.
Bye.